from the superposition theorem. Because in the last video lecture we had finished the first unit and started the second unit also, in which we have seen the superposition concept. Today we'll start with the problem on superposition theorem, and last time I gave you some homework. I hope you people have done that. So here we go, we'll start the session. Friends, the problem is given and he is asking that use the superposition theorem to find V. Where is the V? Here is the V in the circuit of given figure. I'll take this on a fresh page. Wait a minute. See, the problem is given. This is 8 ohm connected with 6 volt battery. Here connected with 4 ohm resistance. Again in the circuit I am having current source 3A. Is it okay? Now the voltage is given across this like this. Now the question is find out V. What is the value of V? They are asking. And we have to solve this by SPT, superposition theorem. Okay. As the superposition theorem says, if we are having more than one independent source, here we are having 2 independent sources. This one is the voltage source, this one is the current source. So we can apply individually to those independent sources and find out the response of each. Then at last we have to algebraically sum all of the responses. Okay. So here in the first step I'll keep 6 volt and turn off 3 ampere current. Is it okay to you? Now how to keep 6 volt? I'll keep 6 volt in the circuit as it is, like this, and this 8 will be like as it is, this 4 will be as it is, and I have to turn off the current, and you know the current source will be open circuit. Is it okay to you people? Now come. This 6, 8 and 4, correct? Now I have to calculate voltage across 4. Now it's depend on you how you will find out this voltage, whether you are applying the voltage division rule, or you will find out the current, then will multiply with the resistance value, then we'll get the value of voltage. Any method you can do it. See, suppose you will find out the current. So current is nothing but 6 divided by 8 plus 4. Is it okay? So this one is nothing but 0.5 ampere. Now if you have the 0.5 ampere current in the 4 ohm resistance, you can easily find out the voltage, and this voltage is 0.5 into 4. So the resultant is 2 volt. So you have find the value of V1, that is 2 volt, and you know the direction. If this is 4, so direction of this 2 volt is like this. Is it correct? Because current is coming from the upward side, so voltage rho will be like this. I hope this one is clear to you. So please keep it here, V1 equal to 2 volt. Fine. Now in the next step I'll remove this voltage source and I'll keep the current source in the circuit. Okay. Fine. I'll keep, this is 3 ampere and turn off 6 volt. Is it okay? How to turn off the voltage source? By making it short. This 8 as it is, this 4 as it is here, and this is the current 3 ampere. Is it okay? Now your task is to find out the voltage across this. Is it okay? Now see, if you are having current in this 4 ohm resistance, you can easily find out the value of voltage. Is it? So see, 3 ampere current is coming over here. Now this 3 ampere current seeing two parallel connected elements. So current will divide. So by the current division rule, you can find out the current in 4 ohm resistance. Suppose I'm giving the name I4. This I4 is nothing but the main current or source current 3A multiply with opposite branch resistance. Okay, fine, opposite branch resistance divide by summation of all. So this is 12. 3 4 ja 4 2 ja. So you are having 2 ampere current. If you are having 2 ampere current, so voltage, initially I gave V1, here I'll give V2. So your voltage will be 4 multiply with 2. So finally you are having 8 volt. Is it okay? Now see the direction of this V2. Again the same direction as V1. Same direction. 8 volt. Now what is the resultant then? Resultant is V1 plus V2. Remember the algebraic summation means we'll consider the direction also. The direction of V1 and direction of V2 both are same. That's why positive sign. And the value of V1 is nothing but 2. The value of V2 is nothing but 8. And finally we are having 10 volt. Is it okay? So this is the way to solve the problem by SPT. Okay, the simple circuit I can solve by node analysis also. This is the simple circuit, that's why node analysis is very easy rather than use the SPT. Okay, but for the big circuits the SPT is very useful. Okay, see how you will solve the same circuit by nodal analysis. Here V minus 6 divided by 8. Is it correct? V minus 6 minus 0 divided by 8 plus V by 8. This, sorry, 4 it is, 4. Incoming current is 3 equal to 0. Correct? Here the LCM is 8. V minus 6 plus 2V minus 24 equal to 0. 3V equal to, tell me, 30. Is it okay? V equal to 10. Simple. Okay. Now come to the second question. The second question contain dependent source. So I'll show you how to solve the circuits having dependent source in it. Okay. Okay. The question is, this is 4 ampere. Okay. Fine. Connected with 3 ohm. And this is 5 ohm, 1 plus minus 5 I naught. This is 2 ohm, 4 ohm. This is 20 volt. Is it okay? How many independent sources are there in the circuit? Here this is I naught. So this is the dependent source, and this dependent source is depending completely on I naught, the circuit parameter. Okay? Fine. The question is find out the I naught. The question is find out the I naught. Okay? And I naught by SPT only. The condition is by superposition theorem we have to find out. So according to the superposition theorem, here in this network, we are having two independent sources, 4 ampere current source and 20 volt voltage source. So one by one we are going to take in consideration, and in the first step I'll keep 4 ampere current in the circuit and will turn off 20 volt source. Is it okay? So how to turn off? We'll make it short circuit. Okay. So in this figure only I'm doing this. I have to short circuit it. This is the short circuit. Now the scenario is changed. Initially we are having two independent sources in the circuit, but now we are having only one independent source, and that is 4 ampere current. So if initially our current, this current is I0, now I am assuming this is I0 1. Wherever we have I0, we'll give the name now I0 1. Okay, 1 indicates that this is because of the first energy source we are considering in the circuit. Now, see, now we have to apply KCL or KVL in the circuit. If we will apply KCL, we are having how many nodes? A, B, C, and this is the ground node. So 3 equations we will be having and 3 unknowns we will be having. So better to go with KVL. Why KVL? Because see, in this we are directly having the current. Directly we are having this current 4 ampere. Okay, in this we will assume suppose I2, and in this we will assume I3. Okay, so once we will solve this circuit, and when we will write the equations, there is no need to go for this mesh. Why? Because we have already the mesh current. See, while solving by KVL, we assumed I1 and I2 and I3, right? Here we are having 3 meshes, but for one mesh I have the value of I1, so the remaining variables will be only I2 and I3. So here by to do this circuit by KVL, we encountered with 2 variables. The same circuit, if we will do by KCL, we will be having 3 variables. So better to go with KVL. Is it okay? I hope. Now we will go by KVL. Come to the KVL now. Okay, KVL says we have to assume the mesh currents. Here is the 4 ampere already given. Here is the I2, here is the I3, and I assume the direction also. First, we'll take the mesh B, C, A, B. B, C, A, B. This mesh, I'm applying KVL. Okay, I'm starting from here. The voltage drop across this is like this because direction of current is this. Minus 2I2, I hope it's clear to you people. Now come to this side. Here we are getting plus 5I01. Plus 5I01. Any problem yet? Now come here. The drop is this. So minus, obviously the value of resistance is 1. Current is I2 minus I3. Why? Because I3 is coming from this side. I2 is coming from this side, and as per our assumption, the I2 is higher than I3. That's why I'm subtracting I3 from I2. And come to the 3 now. This minus 3 again. The current is I2 minus 4. 4 is the current coming from this side. I2 is the current coming from this side. Is it okay? And I2 is greater than 4. So I2 minus 4, and the value of resistance is 3, and the drop is plus minus. So I'm taking it minus sign. Is it okay? We can simplify this equation further. 2I2 plus 5I01 minus I2 plus I3 minus 3I2 plus 12 equal to 0. Is it clear to you? Now come next. Minus 2I2 and minus 3I2 and minus 6I2. Total I'm having 6I2. Okay, fine. Now what about the this? Okay, 5I01 fine, and plus 12 also we have in the equation. It's equal to 0. Is it clear to you? Minus 6I2 plus 5I01 plus 12 equal to 0, and like this the situation is. Okay. So this is the equation 1. Come to the mesh A, C, A now. A, C, A. Okay. I'm starting from here only. I'm getting 1. In this mesh the current is I3. The sign is negative. Minus I2. Fine. Okay. As I move forward, I'm getting minus 5I01. Is it clear to you? Here I'm getting I3 minus 4I3 only. Again I'm coming here, I'm getting 5, so minus 5, and the current is I3 minus 4 equal to 0. Is it clear? 4 is coming from the upside, and from the downside I am having I3. So resultant is I3 minus 4 and multiply with 5. Okay, again I'll simplify this. I'll get I3 plus I2 minus 5 I0 1 minus 4 I3 minus 5 I3 plus 20 equal to 0. Is it okay? Now see, 5, 4 and 1 minus 10 I3. Is it clear? What about I2? I'm having only single term of I2. So this is I2. Where is the I3 in this equation? Sorry. I3 is here also. I3. In this equation, I3 is. Okay. Anything else? Yes, only I3. So minus 10 I3 plus I2 minus 5 I0 1 and plus 20 equal to 0. Now see, if you carefully observe these two equations, you are having two equations but you are having three unknowns. So we need another equation to find out the unknown, right? So come here. What is the value of I0? In this circuit, what is the value of I0? I0 is the current coming from the upward direction. So upward is, the current is 4 ampere, and from the down the current is I3. So this I0 is nothing but 4 minus I3. Is it okay to you people? Right? What you will do, you will replace I3 by 4 minus I0. I3 you will replace by 4 minus I0. Is it okay? This is equation 3. Now you are having three equations, three unknowns. Easily you can find out the I0, and your I0 will be 52.17 ampere. This is I0 1, okay? Okay, this I0 1 is nothing but, in the first case, we'll be having I0 1 is nothing but 52 by 17 ampere. Okay? And the direction of this is from A to ground. Means this is in this way. Okay? Now, come to the second one, second independent source. Okay, so I removed all this. In the second case, we have to keep the voltage source as it is, and we have to turn off the 4 ampere current. So here I'll keep 20 volt and I'll turn off 4 ampere. Okay, how to turn off this? See, you have to open this from the circuit. There is no current now. Okay, I'll erase everything. Okay, nothing is here now. Okay, if your circuit is here, I have to apply the battery. Now I'll draw the remaining circuit. This is 20 volt. This is open circuit. Again, this is 5. In this 5, the current I0 2 is coming now. Okay, this is 3, and this is 5 I0. It will be 2 now. Is it okay to you people? Now the task is very easy for you, because you have to find out this I0 only. Okay, so this branch is the open branch. Means we can remove this branch from the circuit. There is a open circuit across B and ground, like this. This is your simplified circuit. Okay, and our task is to find out the I0. What we are going to do here now? Tell me. We'll apply again KVL here in this equation. We'll assume two currents. Okay, wait a minute. We'll assume two currents. One is here, and assume this I0 already, like this in this circuit, like this is the I0 already given this circuit, this current. Okay, now here I am taking I1. Now I'll write the KVL equation. I'll start with the B, I'll come back to the B. Now minus 2I1. Okay, fine. plus 5 I naught 2. Okay, fine. Here minus I1 in this. See, I assume this current in this way. So this current is I naught is going this way, I1 is also coming to this way. So both added, I1 plus I naught 2 I gave the name, right? I naught 2. Is it okay? Where is the end? End is at the B. So again I am getting minus 3 I1. Is it okay? And equal to 0. Again you can simplify this, minus 2 I1 plus 5 I naught 2 minus I1 minus I naught 2 minus 3 I1 equal to 0. Is it okay? So minus 2 minus 3 minus 6 I1 plus 5 I naught minus I naught, so it will be 4 I naught 2 equal to 0, equation 1. Correct. Now come to the second mesh. We'll start from here. I'm getting 1 ohm first. So the current is, my direction is this, and both currents are coming from the opposite sign. So minus 1 and current both are coming from the same direction. I naught 2 plus I1. I'm getting minus 5 I naught. Here I'm getting 4, and the direction of the current is like this. So I'm getting plus 4 I naught 2. Here I'm getting plus 20, and this is 5 also. 5 also I'm getting 5 I naught 2. Why I'm taking plus sign? Because now current direction is from the upward side. So the drop is like this, and I'm moving in this way. Okay, so it will become positive sign at the end. So it is 0. So 2 equation, and you will solve the equation. We will get I naught is minus 60 by 17. What it means minus? Minus means the original direction will be this, and the given direction is this. Now we have to take the resultant. Here is the resultant IR. Initially we got 52.17. The direction was downside. Again we are getting minus 60 by 17. Minus, if I'll keep minus, so it is automatic this direction. Is it okay? Directions are same. We can say directly this is minus 8 by 17. This is our answer. So this is the lengthy way to solve the circuits by superposition theorem, but sometimes it's very easy. Okay, in the GATE we have, in 1 year we get one question. The question was, I think same question we solved last time. The question was, see, like this. This is 1 ohm, 1 ampere current. This is 1 volt battery, and this was given I, and the question was to find out the current I. Sorry, take pen here. The question was find out this I. Find out I. So this same question I can do by SPT also. How? First I'll keep this and I'll remove this. So I'm keeping this 1 volt as it is, this one as it is, 1 ohm resistive branch, and this is open circuit. Open circuit means there is a no circuit over here. There is no current in this circuit. I equal to 0. So this is the dead. So I'm having the new situation. I'm giving the name I1. So what is the I1? 1 by 1. I1 is nothing but 1 ampere. Is it okay? Now come by second one. Means you have to apply the 1 ampere current in the circuit, and you will turn off this circuit. How to turn off the voltage source? By making it short. And this is 1. Okay, fine. This is current source. Okay, fine. This is the current I. Now this is the 1 ampere current. 1 ampere current is coming over here. Now where it will go? See, in this path current is getting short circuit. So current always goes in a short circuit path. Short circuit means minimum resistance. Minimum resistance. So current will always go in the full current will drain to the short circuit. Here only zero current will go, I equal to 0. So here this is 1 ampere fully will go in this short circuit. So what is the value of this I2? This I2 is nothing but minus 1 ampere, right? Because I2 is coming from this direction and 1 ampere is coming to this direction. They are opposite to each other. So I can say I2 is nothing but minus 1 ampere. I2 is not 1 ampere. If 1 ampere will be go like this, then I can say I2 is nothing but 1 ampere. But here it's coming from the opposite direction. So I2 is minus 1. So finally you are having resultant, I'm telling, I1 plus I2. Algebraic sum means consider the direction at a same direction. I1 is nothing but 1 and I2 is nothing but 1 equal to 0. So our answer is 0 ampere. By SPT we did this. I hope SPT is clear for you. Come to the next one, and that is the source transformation. Source transformation we have discussed in the first unit also. This source transformation is also a tool to simplify the circuit actually. Sometimes we get the voltage source in the circuit, so we can convert that voltage source in the equivalent current source, and maybe it will make easy the circuit analysis. That's why we are employing this. The source transformation says this is the another tool for simplifying the circuit. Basic to this tool is the concept of equivalence, means the both circuit will be equivalent to each other. Remember in the first unit we have seen the voltage source will be connected in series with the resistance, and when we are converting this we are getting one current source, and current source always given with the parallel resistance connected to it. Okay. So what is the Is now? Here the value of Is by Ohm's law is nothing but Vs by R, simply Vs by R. So now we can say these two circuits are equivalent to each other. Means they will not introduce any change into the circuit. They are equivalent to each other. Okay. If this one is the 100 rupee note, you convert it into 50 rupee notes and 2 notes. Is it okay to you people? A source transformation is the process of replacing a voltage source Vs in series with a resistor R by a current source Is in parallel with a resistor Rc. You know already. Okay. What if we are having the dependent source in the circuit? Dependent source is given. So the same theorem, same concept we can apply for the dependent source also. But the values of dependent source at a particular point should not change. See, source transformation also applies to dependent sources, provided we carefully handle the dependent variable as shown in given figure. A dependent voltage source in a series with a resistor, same thing. This is the voltage source in series with resistance. We converted into the current source in parallel with the resistance R. Is it okay? Now we have to remember that the circuit situation should not change while applying the source transformation in independent source or dependent source. Okay, we will see in the problem how. See this circuit only. This circuit contains one current source in parallel with 4 ohm resistance. I can convert this circuit in the form of equivalent voltage source. So the direction of your equivalent sources will be like this. Current is flowing in this direction. Is it okay? And in series with resistance R. See this. This is the point AB. Okay, this is the point AB. Here is the point AB. Everything is same. Now, the situation or the direction of the voltage source is like this. Is it okay? And this is nothing but 4. What about this? use source transformation to find out the V0 in the circuit. Now we will see how the source transformation technique is very useful to make it very simple for this circuit. I'm telling. See, this is the point A, this is the point B. Suppose in between A and B we are having one current source connected with parallel with resistance R. So can we apply source transformation here? Remember, the circuit parameter should not change. This is 2 as it is, this is 8 as it is, and this is V0 we have to find 3 and 12. 3 and 12. Okay. And across this we'll replace this entire circuit by 4 and the battery. See, this is the battery. Current is going A to B here. The current is going A to B in this circuit while replacing this. Why I'm taking polarity of this battery like this? Because the current in this circuit will go from A to B. Here also the current is going from A to B. That's why. Is it okay to you people? Now the circuit is like this. Don't change to this branch because we have to find out the V0 across this branch only. Now again, if you will observe this circuit carefully, you will see in this circuit that again this 4 and 2 they are connected in series. So resultant I can replace with 6 first. The resultant of these two terms I can replace by 6 first. Okay. Okay, I'm going to reply this is 6. This is 6 ohm. Now, can I again replace this by again current source? Yes, I can. So I'll replace this. So when you will replace this minus 12 like this, it's given 6 by equivalent current source. It will be the current direction is in the lower direction. This is 6 already and the current value is 2 ampere. Is it okay? This is the replacement of this. So I'll replace this. Here it will be 6. I'll remove this branch from the circuit and replace by current source. Okay? Good. This is as it is like this, and this is nothing but 2 ampere. 2 ampere. Is it okay? Now again, don't change this branch because we have to find out this only. Now come to the this branch. Can we replace this also? Yes, I can replace this one also. So we'll replace this by 3 in parallel and the value of current is nothing but 4 ampere. Is it okay? I hope it is clear to you people. This voltage source I replace by this circuit. It's very easy, okay? Okay. Now your new circuit is, I'll make it clear. Your new circuit is like this is 3 ampere and this is this is 4 actually and this is 3 ohm. The new circuit is like this. Now here the voltage is V0. See, this V0 is nothing but the voltage across this point. Now apply the KCL simply. Okay, so you'll apply the KCL over here. So you'll get V0 by 6, this one V0 by 8, V0 by 3, 2 ampere is outgoing current, 4 ampere is incoming current equal to 0. Is it okay? Finally, we can take here 24 as a LCM and 4 V0 plus 3 V0 plus 8 V0 equal to this 2. Okay. 4, 3 and 8. So this is total 15. 15 V0 is nothing but 48. V0 is nothing but 48 divided by 15. This is our answer in volt. simple source analysis, source transformation, something. I hope it's clear to you. This one I'm leaving for you. Is it clear to you people how to apply source transformation and what is source transformation actually? We can convert the current source into the equivalent voltage source. Means both are equal. They are not going to change the value in the circuit. Okay, come to the next one now. This is again source transformation based problem, and will you do it or I'll take for you? Okay, I'm taking it. Okay, we'll apply the source transformation here. Right? So, see this. I can apply over here source transformation. Your circuit will be 2, 6. This will become, this current source will convert into voltage source, resistance in series with direction of the voltage source will be this side only. The value of voltage is current into resistance, that is Vx itself, and this is 4 connected with 18 volt. Fine. Here is the branch in which we have to find out the Vx. This is 2. Now simply here the voltage is Vx. I can apply KCL over here. This is the Vx. Now Vx across this 2 and 2 is connected between point A and ground. So this is the Vx. So I'll apply the nodal analysis over here. Vx minus 6 divided by 2. Vx minus 6 divided by 2 plus Vx by 2 here plus this Vx minus 18 divided by 4 equal to 0. I'll take LCM over here. So this will be 2Vx minus 12 plus 2Vx, and it will cancel out and it will be minus 18 equal to 0. 2Vx, 2Vx, 4Vx minus 12 minus 18 equal to minus 30 equal to 0. So Vx equal to 30 by 4 volt. This is our answer. Very simple. Correct? Now come to the Thevenin theorem. Very important theorem. Okay. Thevenin theorem. This one is very important. Okay. Very, very important. 80% chances to get problem from this theorem based only. They'll not say, they'll not give the problem and they will say they apply the Thevenin theorem. No. They'll give the problem, we have to solve by any method. We have to apply directly KCL or KVL or SPT or anything, source transformation, whatever we know. But to apply the Thevenin theorem in the circuit, sometimes it makes very easy to the solution. Okay. So, what is the Thevenin theorem actually? Suppose you are having a very lengthy circuit. So many elements. These many independent sources also in the circuit. And like this, many independent sources again. And here across point A, B, a resistance is connected, R, L. And they are asking find out the current I over here. So this circuit contains so many elements, independent sources. So Thevenin theorem says this entire circuit I can replace by single voltage source and single resistance across the point A and B. Suppose A and B is the point across which I have to make this circuit very simple. So according to the Thevenin, across point A and B, I can replace this entire circuit by single source and single resistance. Means the equivalent of this circuit will be like this: VTh, fine, and R equivalent. This is the point A. This is the point B. This is the original point, whatever we have seen in the original network. The same point over here. But change is what? This entire circuit I replace by equivalent, one single source, single resistance circuit. Here is your load resistance R. Now they ask to find out the current I. Now simply tell me what is the I. I is nothing but VTH divided by R equivalent plus RL. RL and R equivalent, they are connected in series. So this is the summation. And according to the Ohm's law, V equal to Ri, I equal to VTH by. This is our answer. So this is nothing but the Thevenin's theorem. Now come to the statement of the theorem. Thevenin theorem says, Thevenin theorem states that a linear two-terminal circuit, remember, two-terminal circuit can be replaced by an equivalent circuit. This is the equivalent circuit consisting of a voltage source VTH in series with resistance RTH, where VTH, okay, see, the Thevenin theorem is saying that linear two-terminal circuit across A and B or across two terminal, I can be replaced with a single source VTH and RTH across the A and B, where VTH is what? VTH is nothing but the open circuit voltage at the terminal. This VTH is nothing but the open circuit voltage across this terminal A and B. And the RTH is the input or equivalent resistance at the terminal, and the RTH is nothing but the equivalent resistance of the circuit across the same terminal. Is it okay? So like this we replace, and once we replace, the IL is nothing but VTH divided by RTH plus RL. Okay? Is it clear to you? If not, then we'll take one example in which it will be clear to you people. Okay? Fine. So here we are having two parameters, VTH and RTH, right? In the resultant circuit, you are having two parameters, VTH and RTH. So this is a simple doubt that how to find the RTH and VTH. Okay. What is the VTH they are saying? They are saying VTH is nothing but, see, if this is your linear two-terminal circuit, complicated circuit, now your task is to find out the VTH, and according to the definition of VTH is open circuit voltage across point A and B or across the terminal. See, this is the terminal, this is the reference point. Means across the terminal we are shorting the circuit or we are simplifying the circuit. Is it okay? So open circuit voltage means we'll open the two terminal A and B, we'll find out the voltage across the two terminals, and that voltage will be nothing but the VTH. See, we'll open A and B, we'll find the open circuit voltage here, and this open circuit voltage is nothing but the VTH. What about RTH? RTH also will open the circuit A and B, will keep open 2 points A and B, will find the resultant of this circuit, and that resultant will nothing but the RTH. Is it okay to you people? Okay. When we'll take the problem, it will be clear to you again. Now find the RTH. So while finding out the RTH, we encountered with the two conditions. Okay. So I'll come later over here. Before that, we'll take this problem for you. Find the Thevenin equivalent circuit of the circuit shown in the figure. To the left of the terminal A and B, this is the terminal A and B. So we have to find the resultant of the circuit of this circuit. Okay, and they are asking then find the current through the RL equal to 6 and 16 ohm. If RL equal to 6 ohm, if RL equal to 16 ohm, we have to find the current. So first we will resolve this circuit. I'll take this circuit on the fresh page. Okay, the circuit is, this is 32, 4 ohm, 12 ohm, 2 ampere current, this is 1, and here we are having load resistance, and this is the terminal across which we have to find the Thevenin equivalent circuit. My task is find out the Thevenin equivalent circuit Thevenin equivalent circuit across AB. Is it clear to you? Now see, the Thevenin equivalent circuit for this circuit is here. VTH, RTH, this is the same terminal A, and this is B. That's it. So here I have to find the value of VTH and RTH. Now according to the definition, the VTH is nothing but open circuit voltage. Remember, in the statement we have seen open circuit voltage. Open circuit voltage means, to calculate this VTH or open circuit, we'll open the A and B, means we'll remove this load from this. This A and B now open. The entire circuit will be as it is. This is 2. Okay. This is 12. Fine. This is 4. This is 32. Now we have to find this open circuit voltage, and this open circuit voltage is nothing but VTH. Now how to find this open circuit voltage? See, this is the open branch, so is there any current over here? No. This is the no current is here in the circuit. So if voltage here is VOC, the same voltage will be having here only, VOC. Is it okay? Tell me any problem. In this circuit, in this branch, there is a zero current, there is a no drop. Whatever voltage we are having across VA, the same will be having it here only. Is there at this point? Is it okay? So this is VOC. Can I apply nodal analysis? Yes, these two are the same point. So VOC minus 32 divided by 4 plus VOC divided by 12, and minus 2 is the upcoming current, and there is no current in this branch, equal to 0. Is it okay? Now only one unknown, and that is VOC. Take 12 LCM, 3 VOC minus 96 plus VOC minus 24 equal to 0. I hope it is clear to you. 3 and 1 for VOC. Okay. And this will be 120. So VOC is nothing but 30 volt. This is nothing but the VTH. So you find out the VTH. VTH is nothing but 30 volt. Okay, fine. Now you need RTH also. So in the statement we have seen the RTH is nothing but the open circuit or equivalent resistance across which point? Across point A and B. Okay. This is the point A and B. See, A and B, across this only I have to find the equivalent resistance, right? Equivalent resistance. See, what is the procedure to find equivalent resistance? In the last video lectures, in the first unit, we have done this. Now we have to find the equivalent resistance, or Rin, or R equivalent across A and B. So all voltage source I'll shut down. We have to turn off the independent sources. How to turn off the battery? By making it short. By making it short. How to turn off the current source? By making it open. Like this. Is it okay? This will be short circuited. This is the resultant, right? What is the value of this C? Now 4 and 12, they are connected parallel to each other. 4 into 12 divided by 16, 4 4 ja, 4 3 ja. The resultant is 3. This 3 and this 1, they are connected in series. So R equivalent is nothing but 4. So here the value is 4. Is it okay? So see, your resultant circuit is now, Your resultant circuit is VTH, that is 30 volt in series with 4. Now you replace the entire circuit across A and B by single source and single resistance. Where's the single source voltage is? The single voltage source is nothing but the VTH, that is 30 volt, and RTH is nothing but the R equivalent of the circuit. Here now whatever load is, no matter, we can easily find out the current. The current is now 30 divided by 4 plus whatever the value of RL is. Okay, now you can put the RL as whatever they are asking in the question, and you can find out the current easily. Okay, this is the way to solve the circuit by Thevenin theorem. So friends, see one more thing here. Wait a minute. See, we have seen we are replacing the circuit by single source, that is VTH, and single resistance, that is RTH, and we are replacing this circuit across the terminal A and B. Is it okay? The VTH is nothing but the open circuit voltage, as you know. This is the open circuit voltage. RTH is the R equivalent across that point. So we know the method to find out the RTH or R equivalent across any terminal. Okay. See, in the first unit, okay, I'll make it clear again to you people. In the first unit, we have seen the question like this. I'm drawing for you again. They were giving us the terminal A and B. They were giving the values of resistances 2 ohm, here 2 ohm, 4 ohm and 4 ohm. They were asking find out the R equivalent. Find out the R equivalent. What we were doing, we were starting from the ending portion of the circuit. 4 and 4, they are connected in parallel. So the resultant of this 2 will become 2. Okay, 4 into 4 divided by 8. Like this. This is the R equivalent. Now again the 2 and 2 are their series. So R equivalent is nothing but the 4 ohm. Is it okay? This was the very simple circuit. But suppose in the same circuit, for the same circuit I'm telling, if instead of all resistive elements, suppose we are having dependent source also, independent battery also over here. What I'm telling is, here you have 4, here you have 1 battery also. Let's take 50 volt. Now they are asking find out the R equivalent. See, this independent source will not affect the value of resistance across the point A and B. Okay, so it is here or not matter. These independent sources are there in the circuit or not in the circuit, no matter to R equivalent. R equivalent will not change. Is it okay to you people? So while solving the circuit, if we are having the voltage sources, short circuited them. If we are having current sources, open circuited them, and then find out the RTH. What I am saying is, in this circuit, first we will simplify the circuit because the independent source is given. So you will turn off that source first. How to turn off the voltage source? You know, to short that. To short the independent source. Here the situation is same. Again, the 4 and 4 they are connected in parallel combination. So resultant is 2 and 2 connected in the series connection. So finally is R ohm. No change with battery. But instead of this independent voltage source, you are having independent current source. So suppose, okay, your new circuit is like this. This is 4 ampere current. Now they are asking what is the R equivalent. Fine. So what is the procedure? Procedure is, if current source is given, I'll open it. So this is 2, this is 4, This is 4. Here the current source is given. I open the circuit, and this is the A and B. The situation is same. Find the R equivalent. Now this is the open circuit. This is the open circuit, means this you can remove from the circuit. There is a zero importance now of this element in the circuit. Why? Because this is the open. This circuit is not providing anything in the circuit. Okay. So the resultant is 2 and 4, they are connected in series. R equivalent is nothing but 6. This is the simple approach to do this. Okay. Is it okay? But sometimes what happens, when you will solve the circuit, we encountered with the case 2. Case 2 says, case first, I told you already about case first. If the network has no dependent source, we turn off all independent sources and then find out the RTH. RTH is the input resistance of the network looking between terminal and AB. Case first says this is the approach to find out the RTH. While finding out the RTH, we are not getting directly resistive circuit like this, that your circuit is purely resistive given over here, and they are saying find out the R equivalent across A and B. We are not getting directly circuit like this. We are getting some independent sources are given, some independent voltage source or current source given in the circuit like this. That's why this first case is coming into the picture. It says that if the network has no dependent sources, means only independent sources, we turn off all independent sources. So we have to turn off them all. We have to turn off all dependent source and find out the R equivalent. But friends, if instead of independent source we are having dependent source, so we can't turn off. We can't turn off them. Dependent source, because the value of dependent source depends on the circuit parameter. That's why we can't turn off them. Are you getting what I'm saying? So if we are having dependent source in the circuit and we are going to find out the RTH, how we will find? We'll see in the problem. Okay, I'll illustrate in the problem well. But here what they are saying, we turn off all independent sources. Yes, we'll turn off all independent sources, no problem at all. As with the superposition, dependent sources are not to be turned off because they are controlled by circuit variables. As I told you earlier, we apply a voltage source, we know this is the procedure. Then how to find? I'll illustrate this in an example for you. See, come here. I'm taking this circuit for you. The given circuit is $5 ampere current, in parallel with 4 ohm resistance, and across this resistance Vx is given. Fine. This is 2 ohm. Here the dependent source is given, minus plus, value is 4 Vx. Here it is 6, here it is 2, A and B. Okay. Now we have to find out the Thevenin equivalent circuit over AB. Means I have to replace this circuit by VTH and RTH. This is my task. So what is the VTH? VTH is the open circuit voltage. What is the RTH? RTH is also the open circuit equivalent resistance over the point A and B. Here first I will find out the VTH. Okay, can I remove this circuit? Okay, fine. see here. Here the voltage is VTH because these two branches are open, these 2 points are open, not connected. Open circuit voltage is nothing but the VTH. Here is the VTH. If this circuit is open, is there any current here? No, zero current. So there is a no drop. So this entire VTH is nothing but the voltage across this point. Do you have any problem? No? Good. Now come to this circuit. We'll smash the circuit. See friends, the Vx is given across this. If the voltage across 4 ohm resistance is Vx, then tell me the current across this and direction of the current. Will the direction of current will be like this? That's why we are getting the polarity of voltage drop in this way. And what will be the value of this current? This current will be nothing but Vx by 4. Is it? Tell me any problem? Very good. So we are having the current over here and the voltage over here is Vx. Can I apply the nodal analysis at these 2 points? Here and here? Yes, I can apply. So we will apply this. And this is the super node concept. Why? Between 2 points, if one dependent and independent voltage source is connected, so we are having the super node concept. So point A and B apply here. Here is the Vx. Vx divided by 4. This is the current, right? And 5 ampere is incoming current. Fine. Vx minus Vth. Vx minus Vth divided by 2. I hope this is clear to you. Now because of this branch, I have to apply or I have to consider this point also in single equation. If you remember the super node concept. So here the VTH also I will consider. Means the nodal analysis of these two nodes I will write in a single equation. VTH divided by 6 plus VTH minus Vx. VTH minus Vx by 2. Is it okay? What about this branch? There is no current, zero current, equal to 0. So, is it okay to you? Now, come VTH. Now take the LCM, and that LCM will be 12. 4 3s are 3Vx minus 60. Okay. This minus sign, man. Vx minus Vth, this is the positive sign, right? This is the positive sign. So now if you will see this and this will be cancel out to each other. Yes, they will cancel out. Now it will be 2Vth equal to 0. So finally 3Vx plus 2Vth equal to 60. Is it okay? Now this is equation 1 and another equation is given here. Vx minus Vth is nothing but this. Vx minus Vth is nothing but already given. What is this? This is 4Vx. 4Vx is given with negative 4x given. Vx minus Vth is equal to negative 4Vx. So the 5Vx is equal to Vth actually. I need Vth, I'll replace this Vx in this equation. Okay. So this is 3, this is Vth by 5 and plus 2Vth equal to 60. So finally Vth is nothing but it's 3 by 5. So 5 over here, 3 Vth plus 10 Vth equal to 60. 13 Vth equal to 60 into 5. So Vth is nothing but 60 into 5 divided by 13. Okay. Okay. The Vth is over. This is the procedure to find out the Vth. Now come to the RTh. Okay. Vth is 60 into 5 divided by 13. Now come to the RTh. Now what is the RTh? Again we will open these two points A and B. Here I will find the RTh, means R equivalent. or R in. This is nothing but RTH. Is it okay? So we know the procedure. Whenever we are having deep independent sources, we can open them. We can turn off them. So here the current source is given, the current source will go out. It will be open completely. There is no current source in the circuit now. The circuit is like this, but we can't do with a dependent source, right? Dependent source will be as it is in the circuit. We can't touch the dependent source because the dependent source is depend on the circuit parameter. So what I'll do to find out the RTH? Here is my assumption. If you want to find out the RTH across point AB, do one thing. Apply one outer battery source over here, V, and due to this V, the circuit current is I. And if you are able to find out V by I somehow, so that V by I will be nothing but the RTH. Is it okay? This V by I is the resistance seen by this source or not? That resistance seen by this source will be RTH or R equivalent of this circuit or not? Tell me. This is like this entire circuit you replace by R equivalent, and here your battery V, current is I. So according to the Ohm's law, this entire thing is R equivalent or not across this point A and B. Is it okay? That's why. Here is this. Now come to, so here I applied the battery V and the current from the battery is I. Okay. Now here again I'll solve this circuit by nodal analysis. Here the voltage is Vx given. Here I'll assume the voltage V in. These are the super nodes. So simultaneously I'll write the equation. So this will be Vx by 4. Okay. This will be Vx minus V in by 2. At this node also simultaneously V in minus Vx by 2 plus this V in divided by 6, and this current I is coming in this circuit. So this is I equal to 0. Equation 1. Is it okay? Is it okay to you? See. Now this and this 2 will cancel. You will be having Vx by 4 plus V in by 6 minus R equal to I. Equation 1. Okay. So this is the equation 1. In this 3 unknown, Vx, V in and I. So again relation is given. V in minus Vx is nothing but 4Vx. The relation is given V in minus Vx equal to 4Vx. Is it okay? So 5Vx is nothing but V in given over here. So I'll replace Vx by V in this equation. Okay. And another equation I'll get by this. See, what is the value of I? What is the value of I? This I is nothing but V minus V in divided by 2. Is it okay? So in this circuit, in this equation, I'm replacing Vx first. Vx, V in by 20 plus V in by 6 equal to I. See this. This equation will become this when I will put this value to this equation. This is equation 3. This is equation 4. Okay. So this V in I, V, what is the value of V in? 2I. V minus 2I. This is nothing but V in by this equation. I'll replace this V in this equation. So I'll be having only V and I terms over here. Okay. I'm taking over here to you. This is a simple calculation. That's why I'm doing very fastly. Okay. Don't worry about this. You can solve this. So the equation is we'll replace V in by V minus 2I by 20, V minus 2I by 6 equal to I. Now V by I, your task is to find V by I. So when you find V by I, your answer will be 27 by 13. Your answer will be 27 by 13, and this is nothing but R equivalent. So the resultant of this circuit will nothing but VTH, we found is 60 into 5 by 13, and RTH, that is 27 by 3. This is the resultant of this. This is all about the Thevenin theorem. I hope this concept is clear. In the next session we will take some more problems based on Thevenin theorem, because you know, and I told you, the Thevenin theorem is the most important theorem among all theorems. Okay friends, so do homework and do well, do practice. If you want to become strong in the subject, conceptually strong, you have to solve the problems at your own. So friends, we'll meet in the next session. Till then, take care and bye.